This is a video on an initial condition problem. The question states, find r of t given that r double prime of t is equal to 2 cosine of ti minus sine of tk, and r prime of 0 is 2j, and r of 0 is j minus k. So if I'm given r double prime and I want r, then I can integrate once to get r prime and integrate again to get r. So I start out with r prime of t is the integral of r double prime of t dt. And I plug in r double prime and get that this is equal to the integral of 2 cosine of ti minus sine of tk dt. So now I just integrate each component. The integral of 2 cosine of t is 2 sine of t plus some constant, which I'll call v sub x. Now there's a hidden j component, a 0j, and the integral of 0 is a constant, which I'll call v sub y, and then times j. And the integral of minus sine of t is the cosine of t plus a constant, which I call v sub z, and then times k. I'm given that r prime of 0 is equal to 2j. So I could plug in 0 to get r prime of 0 here. Sine of 0 is 0, so 0 plus v sub x is just v sub x, and I get v sub xi, and then plus v sub yj. Then if I plug in 0 into cosine of t, I get cosine of 0, or 1, plus v sub z k, and that's supposed to be equal to 2j. So now I just set the components equal. V sub x should be 0 because there's no I component on the right-hand side. V sub y is 2, and 1 plus v sub z is 0, so that means v sub z is negative 1. So I get v sub x is 0, v sub y is 2, and v sub z is negative 1. I can plug those back in to my r prime of t equation, and I get that r prime of t is 2 sine of t plus 0, or just 2 sine of t I, plus v sub y, or 2j, plus cosine of t plus v sub z, or cosine of t minus 1 k. So now that I have r prime of t, I want r of t, so I integrate again. And I get that r of t is equal to the integral of r prime of t dt, and I plug in, so I get the integral of the 2 sine of ti plus 2j plus cosine of t minus 1 k dt. So now I integrate that. The integral of 2 sine of t is negative 2 cosine of t plus a constant, which I'll call s sub x. The integral of 2 is 2t plus a constant, which I call s sub y. And the integral of cosine of t minus 1 is the sine of t minus t plus a constant, which I call s sub z. So now I use the fact that r of 0 is j minus k. So I plug in 0, and if I plug in 0 to negative 2 cosine t, I get negative 2, and then still s sub x I. If I plug in 0 to 2t plus s sub y, I just get s sub y. And notice that sine of 0 minus 0 is 0, so I just get s sub z k, and that's supposed to be equal to j minus k. So now I set the components equal again, and I get negative 2 plus s sub x is 0, so s sub x must be equal to 2. S sub y is 1, and s sub z is negative 1. So now I plug in to get my final answer, and I get that r of t is equal to negative 2 cosine of t plus s sub x, which is 2, I, plus 2t plus s sub y, or 2t plus 1j, plus sine of t minus t plus f sub z, which is -1, so minus 1 k. So let's repeat. I get that r of t is equal to -2 cosine of t plus 2 I plus 2t plus 1 j plus sine of t minus 1 k. And I'm done with the problem.